Hey everyone, and welcome to today's episode of AWS Show and Tell for Generative AI. My name is Rob Higuerita. I am a Specialist Solutions Architect here at AWS, and I am joined by my co-host, who's really been here as the host because I've been the one that's been absent for a while, Anil. And then we've also got some guests as well today that have joined us that are going to cover some interesting topics. Anil, I'm going to let you do your introduction first, and I'm going to go Marco, and then I guess Chopper as well.
All right. Thank you, Rob. Nice to see you all here today for another episode of Show and Tell. I'm Anil Nadiminti. I'm a senior solutions architect here supporting Greenfield customers. And we have a very exciting topic today. Chakra and Marco are going to talk about Llama 4 models. But before we get into that, let's chat about, let's go through the introductions here.
Awesome. Yeah, thank you, Anil. My name is Marco Puno, everyone, and I'm a senior specialist solutions architect specializing in generative AI on the third-party models providers team and focused primarily on the model provider Meta. Chakra?
Hi everyone. So myself, Chakravarti Nagarajan. I go by Chakra. I'm a principal specialist solutions architect focused on meta models in AWS. So I'm the same team as Marco, and I'm here to talk about the Llama 4 family models on AWS today.
Awesome. Yeah, that's great to hear. So today I learned, and I knew we had obviously third-party models. I didn't know we had a team that like kind of just specialized in those ones in particular. So that's pretty cool because I know we constantly are evolving and having a number of different ones that are there. So it's pretty cool to see. And like the one you specialize in, Llama, right? And so for the audience, I think it's probably interesting for them to hear a little bit about, what we're going to be talking about today overall. But I know we were talking ahead of time a little bit as we were prepping for the show. Like there's an actual LlamaCon, right, that you guys were at, and there was live llamas there as well as models, or maybe not actual live llamas, but maybe there was just new model versions and stuff that were being discussed. But maybe you want to share a little bit about what you all kind of saw there, and I'm sure the audience would be interested in that as well. And audience, if you were there too, let us know if you were at LlamaCon as well, if you were able to check it out, or if you didn't know it existed, or you knew it existed, but you did get a chance to make it. Let us know if you were able to go and check it out, or maybe catch some things afterwards on it.
And let us know if you actually saw real llamas too, right? Anybody out there?
Because we have like real llamas.
We have people connecting from all over the world, actually. I'm joining from New Jersey. I know Rob is. Are you in Dallas, Rob?
I'm in Austin, Texas.
Austin, yeah. I always confuse, right?
Yeah,
and then we have Chakra and Marco from West Coast.
Yeah. So trust me, I also seen the llamas for the very first time. And so excited. But prior to that, we had really a lot of fun demos, and the keynotes were awesome. A lot of learnings, and especially to highlight the fireside chat between Mark and Satya, where we get to know what are the advancements in generative AI happening and how they are implementing within Meta and Microsoft. So it was really interesting, and there are a lot of cool things. But how can I not mention the customers, right? So we interact with customers on a day-to-day basis virtually, but I happen to meet a lot of them in person. Mm-hmm. And we had our own booth. We get to demo so many things and had a lot of customer interactions. How about you, Marco?
Yeah, I think the case studies itself and really being able to showcase what a lot of customers are doing on top of the AWS platform was really great. Bringing some of the customers such as General Atomics, in addition to Articulate AI, was a great opportunity to be able to speak with Meta and kind of have that three-way type of conversation. With that, there was definitely a lot of different releases. Llama 4, of course, which is what we're going to be speaking of today, but also being able to discuss more of the cookbooks and things of that nature that Meta provided and launched. So being able to discuss those things and kind of leverage those with customers is one of the hot topics that I was able to really enjoy during my time at LlamaCon.
So while you talk about Llama Cookbook, I really enjoyed two demos based on Llama Cookbook. One was about the book character mind map to demonstrate the ability to handle the higher context length. The other one was about reading the entire GitHub repository and asking questions and generating code out of it. Those were really cool, isn't it?
I think so. And we do have a great opportunity to kind of show some of those use cases that Meta has built out and be able to show the audience today what that would look like on top of AWS, specifically our services like Amazon Bedrock. So
Mhm.
I definitely want to go into that. But another topic is some of the other tools that they released during LlamaCon, the prompt
Mhm.
optimization and the synthetic data set generation toolkits. Do you have any insights on that, Chakra?
Absolutely. So, just to reiterate, we already have one tech asset published based on synthetic data generation, which is available in our GitHub repo. So, we are going to dive deep into that. And
Okay.
also, Llama prompt ops is another interesting part. So, I think enough of LlamaCon. Let's get into Llama 4 on AWS. What do you say, Marco?
Yeah, that sounds great. We have a few slides to share with the audience, and I think it'll be great for us to kind of unveil Llama 4 and what that would look like on top of AWS. And then we have a few demos ready for everyone as well.
Nice. So I got to ask though, before we get into like the slides and things like that, right? You said there was a number of different releases that were there that you kind of saw on top of Llama 4. Was there anything that was like really cool that you saw as far as like a specific demo that you'd share, or like anything that was like super cool and launch maybe you didn't get to see but you heard about from the event?
I think there are multiple demos, but we are actually focusing on 5 demos today as part of the session.
Oh wow! So you've got
Nice.
quite a few of them that you're going to go through to kind of show the audience. And so, audiences, like you said, you're watching today. If you've got questions about what we're going to be covering, specifics on, Llama4 models usage, some of the demos that we're going to be going through, make sure to put those in the chat. Like, let us know. Also, let us know where you're joining us from. Like I said, we shared where we're joining from. But if you let us know that, or just anything in particular that you're really interested in kind of getting out of today's show as we go through these different demos, like let us know. We're here. We've got, well, I'm not here to be the expert at all on Llama4 or on what we're covering today, but thank goodness we've got Marco and Chakra here to be able to answer the questions. So, put those into the chat. Let us know. And we're happy to try and answer those questions on the specifics here that we're going to be going through. All right, I'm going to turn it back over to you guys to go through the presentation. Just wanted to make sure the audience know we're here for them. They can feel
Thanks,
free to
Rob.
interact and let us know, if they've got questions on.
Yeah, feel free to throw all the
Absolutely.
questions into the chat, folks. Like whatever you have, like these are our, Chakra and Marco are our experts on Llama 4. So, and all Llama models, I'm assuming, right, at this point. So people are probably at different versions. Llama 4 is newly available. So, they're probably trying to see if it's a fit for them. Should they upgrade? Should they keep the same versions? What's the benefits of, moving to the newer models? Chakra and Marco are here to chat about this.
Awesome. And I'm excited to dive in. We have a lot of exciting content today. If there's any questions, please feel free to just drop them, and we're happy to answer as well. So for today's agenda, we really want to dive deep into why AWS customers choose Llama models
Mhm.
and what that would look like in terms of the new Llama 4 model architecture, dive deep into what it would look like in Amazon Bedrock and SageMaker AI, as those are some of the hosting platforms that customers look to leverage a lot of different models that are open source, in addition to some of the different model selection categories, and wanted to save a lot of time, mostly on the demos and being able to provide the people in the audience some of the resources of the assets that we've built. So want to spend a lot of time on that, but we can quickly go into a few slides that we've created for today. And I really like this slide because it shows how Meta Llama has been the world's most downloaded AI model. Here we can see a graphic from Hugging Face, actually, where we see that there's about 213K Llama model derivatives and more than 1.2 billion downloads. And what this really means to me with this graphic is that with the 213K Llama model derivatives, we're still seeing a ton of customers and developers looking to have a fine-tuned version of Llama. And what this statistic shows is that
Sorry, what do we mean as a derivative? These, just in case no one in the
Yeah.
audience isn't quite sure, like what we mean as far as like having 213K Llama model derivatives. Probably important just to kind of dive in there. And if I jumped in and you were going to go through that in a second, I am terribly sorry. I got really impatient, wanted to know.
Sure.
Sorry.
Absolutely. I mean, so one is the base version coming from Meta. Those
Uh-huh.
are like the Meta gated models. There are multiple other versions of the Llama. These are like customized. For example, I may release my own Llama. Likewise, there are multiple customized Llama version which are called as derivatives.
Okay.
So the
So same but
213,000
different.
derivatives, 13,000. Wow,
That's right.
that's quite a number, right? So people are really looking to customize those models and making use of them in different ways, right? So yeah.
Absolutely. Yeah.
Correct. And you'll see that tons of customers that are looking to go into production, they'll leverage more of the base model in terms of experimentation, and then they'll use that fine tuning process to make their own derivative and then be able to put that into production. So we'll see a lot of customers doing that to improve on not only latency but cost performance as well. This slide here is really what shows the release of Llama 4 and kind of the new context window that we're able to support with the new Llama models. So previously with Llama 3, the context window was only supported up to 128K tokens.
Hmm.
However, with Llama 4 Scout, which is the smaller variant of Llama 4, it supports up to 10 million context windows. However, on Amazon Bedrock, that would be about 3.5 million. And then Maverick also supports about a 1 million context window on Amazon Bedrock. These models are a MOE architecture, meaning that it has active experts in addition to the parameters that it has that it's used to be trained on.
And do you want to break that down as well, Marco? Like, when you say MOE, right? So
Mhm.
break it down for our viewers here.
Yeah. So you could think of a MOE architecture as it's very different from what you would typically see as a dense architecture from Llama 3, where you would have a mixture of experts, and that's what MOE stands for, mixture of experts. And these experts essentially act as mini hubs of being able to grab a specific amount of parameters when you are trying to run inference. And this is able to grab a specific amount of parameters, and it's about 17 billion active parameters out of the, I believe Scout has about 105 uh, billion parameters, and then Maverick about 400 billion. You would only be grabbing that 17 billion active parameters during the running inference, where you're now able to have more of an optimized response that allows us to have more of that longer latency, or not longer latency, but longer context window, in
Hmm.
addition to being able to have the same level of accuracy.
Absolutely. So just wanted to add here. So basically in a MOE architecture, you will have a switch, right?
Hmm.
So totally, let's say you got a 100 plus billion parameter model. So as Marco mentioned, there will be only 17 billion parameters active at a time. So based on the inference parameters, it automatically switches between different experts. So each expert has got 17 billion active. So the switch automatically routes between the experts. That way, it'll provide you better latency than a dense architecture with all 100 plus billion architecture active. Sorry, billion parameters active.
Sure. Yeah, I think that's a great explanation there. Viewers, let us know if you want any follow-up questions. So yeah, please continue navigating this.
Yeah, so just wanted to dive a little bit deeper into some of the different use cases with the new Llama 4 models. Llama 3 previously was multimodal, where it supported both input image and text with output text. With Llama 4, it now has or it leveraged their early fusion process that allows them to pre-train the model with large amounts of unlabeled text and vision tokens, allowing us to have a much more I guess, improved version of this multimodal capabilities, where we're able to support up to 5 input images, where the limit was actually just one image with Llama 3. Additionally, we went over the extended context window. Llama 4 Scout now supports up to 10 million context length, and then additionally, the multilingual capabilities, it has been improved, where it now supports across 12 different languages, which is supporting the global development and deployment of many various applications uh, across the globe. And then additionally, well, we'll discuss this in a few slides later. I think Shakra has a slide on this, but the superior performance at a low cost. You'll see that Llama 4 has a superior price performance optimization across other models while not having to necessarily forfeit any of the uh, accuracy that you would typically see with the larger model. And then, not on this slide, but wanted to highlight a few different use cases like code base analysis and multi doc analysis as well. By having this extended context window, we're able to see unforeseen use cases that we haven't previously seen with other models, or where you would need to leverage different open source frameworks like LangChain and have different techniques to be able to support these different types of use cases like a code base analysis or a multi-doc analysis. To the next slide. So this slide here really just shows the evolution of Llama 3 and Llama 4, where the very most popular Llama variant for the 3.1 release was Llama 3.1 8B. And you can see that a lot of the example use cases is long form text summarization, multilingual conversation agents, and coding assistants. With Llama 4 Scout and Maverick, we definitely can leverage all of the same exact use cases that we've seen with Llama 3.1 8B. However, it has enhanced multi image analysis and long document analysis, in which we'll be able to go over some of these specific use cases in when we go through some of the demos today. So this is the model card, and here we can see that the input, it supports up to about 5 images, with the output being text. We could see a lot of the different multilingual capabilities with some of the supported languages, and the active parameters is about 17B. So the difference between Scout and Maverick is that Scout, being the smaller 109B active 109B parameter model, it has about 16 experts, and then Llama 4 Maverick has about 128 experts that is being used amongst the 400 billion parameters.
Is it not slightly amusing that 109 billion parameters is a smaller number, right? Like when we talk about the scale of the number of parameters and things, and you see, oh, it's just 109 billion, right? Like that's a small number. But then you look next door and you see Maverick and you see 400, and you're like, okay, it really is it's that smaller number. Like it's quite a bit.
Remember, so. Rob, they also announced Behemoth, which is a much bigger model than this.
Yeah. How much is that? Do you know how much that one is? Did they say, or?
I don't remember the number of parameters. I think more than 800 B, if I'm not wrong.
It probably makes them a little shy, I guess, right? So those Scout and Maverick a little shy when it's next to them.
Yeah, that's it. It's a significant difference, but I mean, it just goes into show, like choosing the right model for the right job, like what you need for parameters and things like that are there for it. But just the sheer scale that's in the data that's available for these, so people are starting to realize, a wide variety of use cases. You said all the different varieties of the derivatives and things for their specific use cases based on these, and there's just lots of differences, right? Lots of info in there.
And even on the token, right? The context length here, right? So again, we started at what, like very small context lengths, and now we're talking about million.
Yeah.
And look at those, like 10 million is the size of the context window. I think that's huge. Just in a matter of what, year and a half, 2 years now, just being able to push that through, right? So, yeah.
Yeah, and I remember just last year when Llama 3.1 405B got released, and I thought that was really groundbreaking. And now here we're sitting today with the Llama 4 Maverick, 400B parameters and a lot more efficient. So I think, we're definitely seeing a lot of advancements, and Llama 4 was a great way for us to be able to see not only the maximum context length being improved, but just improving the model architecture as well with the MOE architecture. And with that, we will go over Llama4 availability on top of AWS. I'll pass it over to Chakra.
Thanks, Marco. So though you have multiple ways and means that you can deploy Llama or any models within AWS, in this session we are just going to focus on two services. One is Amazon Bedrock and another one is Amazon SageMaker. Right. So let's talk about Bedrock. So the availability of both Scout as well as Maverick models are already in Bedrock. And as you know, Llama4 or Amazon Bedrock pricing is basically pay-as-you-go pricing. But before I go there, what are the different features of Bedrock supported in Llama4, right? So context window, as you might have already seen, those Scout supports up to 10 million of context length. Currently, Bedrock supports only up to 3.5 million tokens. But at the same time, you can also deploy this model on self-managed options like EC2 or EKS with higher context length. So there are a few optimization needs to be done while you deploy it with higher context length. Converse API, it does support Converse API. Let's say if you are using Llama 3 or prior generations of Llama models within Bedrock using Converse API, so you can use the same with Llama4 as well. And it also supports batch and model eval. That's one of the important topic that we're going to talk today. Like I have one demo based on that, because using model eval, you can actually compare the performance between different generation of the models. And it also supports the Bedrock guardrails. But fine-tuning, model distillation, and custom model import, stay tuned. It's coming soon. So here you can see the pricing model, right? I mean, it's based on like 1 million input and 1 million output tokens. So it's always the combination of both. So take an example on the third row, where we actually put it like a 3:1 input output token ratio. Here is the pricing. If you compare this pricing with any other models in Bedrock, including Llama 3 models, this is much cheaper, right? Can you move on, Marco? So this slide talks about the region-based availability of Llama4 in Amazon Bedrock. So currently it's available in all US region, while some of them are available based on the cross-region inference. Because as you know, Amazon Bedrock supports cross-region inference, meaning so in one inference, the actual deployment might have been done, but you can also use it across the region, right? So two of the regions have the native deployment, while the other two has only the cross regions, and more region availability is coming. Move on, Marco. So let's move on to Amazon SageMaker. So SageMaker, let me start with Jumpstart. See, Jumpstart helps you to one click. So we have done all the optimizations done in the backend, including the container image and inference optimization. Just go to the Jumpstart console, select the model, and you can do a one-click deployment. So currently, there are 3 variants available in Jumpstart, like the Scout, which is in BF16 format, and Maverick in BF16 as well as FP8. And you have a variety choice of instances available for the model deployment. So as you can see, P5 is the go-to instance. P5 is actually based on NVIDIA H100 instances. Each instance has got 8 H100 instance. So that's the go-to instance for a Llama4 family. But you also have an option to choose with the G6E48X large, which is based on NVIDIA L40S instance. So if you have a lesser context length and you want to be more cost optimized with Scout model, then go with the G6E48X large. And this is actually not told outside very much, right? I mean, everywhere you see like you start with H100 or H200, but if you really wanted to do the cost optimization, we have that option available in Jumpstart with a smaller context window.
Now, Chakra, we have the option to deploy the models, use the model readily from Bedrock versus
Mhm.
being able to deploy it on SageMaker and, select the instance type, being able to pick the different instance types, optimize it. So why would somebody pick SageMaker over Bedrock, right? Or vice versa?
Great question. So as you know, Anil, we at AWS, we offer the breadth and depth of offerings. It's like Llama 4, it's no exception to that, right? So for example, you are a data scientist or a ML engineer, where you wanted to have more flexibility and on what you wanted to have, and control the instance type and the inference options, etc. That is where SageMaker could be a great option. Whereas you don't want to get into the infrastructure management or the inference controls, etc., where as a builder you access through Moto 3 SDK with Bedrock, and that is like ease of use perspective. It's more focused for the builder. Rather, I would say the SageMaker or SageMaker Jumpstart is more applicable for data scientists or ML engineer. And moreover, you also have an option to go with self-managed option like Amazon EC2 or even EKS or any container-based services as well. As long as the more control that you want, you go with the EC2, EKS, or even SageMaker kind of an option.
And just to add, Anil, one practice we are seeing that a lot of developers will leverage is they'll actually do a custom model import where they'll fine tune on SageMaker Jumpstart, really take advantage of the ability to own your own script and kind of be able to provide your script and hyperparameters when you want to go through that fine tuning process. And then take advantage of the serverless component of Amazon Bedrock by doing a custom model import job into Bedrock and having that model then be served through our Bedrock platform in a serverless compute fashion where you don't necessarily have to pay for that fine-tuned model on an hourly basis as well. So that's another practice
Exactly.
that we're doing.
So balance between SageMaker and
Yeah,
Bedrock, fine tune
that's
it in
smart.
SageMaker.
That's smart. Our customers are smart, right?
Yeah, they do all the cooking in the, and use the SageMaker to do all of the fine tuning, and then when it's ready and baked, just import that into Bedrock and start.
So
Yeah,
and
and I would ask to the audience that is probably watching the show because I'm assuming they're interested in generative AI and machine learning because that is the general premise of the show. So hopefully that's what they're here for. Let us know if you've used Amazon SageMaker Jumpstart, right, to be able to do your own model deployments. We covered it like the very first episode, right, this season, right, and we covered another show on using SageMaker Jumpstart with I think it was DeepSeek, right, something like that, and our little deep dive and how it's helpful to be able to deploy those. And so, we've got the same option here for Llama models to be able to deploy that. But if you've taken advantage of SageMaker Jumpstart, let us know, how you've been able to go ahead and deploy. If you've got a specific use case that you've been able to kind of do what Mark's mentioning as well, like do your training in there and then take advantage of moving it into Bedrock so that it's easier for you to manage. Let us know how you've been able to use it. So
Sure, and we have a question coming in the chat. Garima is asking how easy is testing and re-architecting as we go through this, right? So,
absolutely.
Chakra,
So
you want
let
to take
me
that?
take that question. So consider if you are using Amazon Bedrock, you are using a Moto 3 library as an SDK where you just provide the model ID. If you are already using Llama 3, just replace that model ID with Llama 4 model IDs. It's as simple as that. So just replace it, and then there is no changes needed from your application side of things. So, but on the SageMaker side, let's say if you have a Llama 3 endpoint running, so you may want to have a different endpoint with Llama 4. But again, with Jumpstart, make that life easy with a one-click button. Once you click on the deploy button, it deploys the endpoint. So from application front end, you may want to change the endpoint URL. So with Bedrock, it becomes much easy for testing between the different generation of the model. With SageMaker, a little bit of a heavy lifting in terms of changing the endpoint URL and then testing. And again, from a re-architecting before that, you may want to do the model eval as well. I will talk about it later. I hope that answers that question. And Yeah, so in terms of the SageMaker Jumpstart availability, currently it's available only in US East 1, but that's not a blocker for you, right? So there are multiple ways and means that you can use within SageMaker. So with Jumpstart, it's available in one click button. While let's say if you want to have more flexibility, you want to deploy it on your own with your own inference script, we do have deep learning container images, leverage them and use it with the regular SageMaker instead of this Jumpstart. So that way, you are not dependent on any region. So you can get into any region as long as you have the instance availability and the inference scripts with you. You are free to deploy it in any regions with the SageMaker AI.
Excellent. And we also have like another comment saying, Chor Chorke is asking a question like, more episodes, hands on, please. So we're getting to that in a little bit, Chorke. So please, this is just coming up, right? We're just doing the tell part before the show part in this case, I guess, right? So that's kind of where we are.
Sure, sure. So, okay, so there are so many models, right? I mean, even within Llama 3 generation, multiple models, Llama 4, it got like two different versions, how to choose them. So what are the different criteria to look at? So there are three major pillars of model selection criteria. One is the accuracy part of it. So how to validate the accuracy, we'll talk about that in model eval section. But in a nutshell, it's better to have a kind of a ground truth validation data set so that you can compare the model's performance versus your ground truth data. So we do have a framework with Bedrock model evaluation in place under it. So we'll talk about that in a bit. And cost, of course, as I highlighted earlier, Llama 4 on Bedrock is much cheaper than any other models in Bedrock. So in a way that Llama 4 justifies the price performance as compared to the previous generation of Llama models. The latency, if you're running a real-time application and with an endpoint, then it's very important for you to measure the latency. So as we discussed about the MOE architecture versus dense architecture, with MOE you get the benefit of better latency. Again, with Bedrock, it becomes very easy to measure the latency. Right. So these are the three ideal pillars what we hear from the customers, as a decision criteria. Okay, so enough talking. Let's get into action. So let's start with the demos. I'll let Marco to go through a couple of notebooks. Then I'll be back again to talk about the model evaluation and a couple of other use cases.
Yeah. So as we're bringing this up, we have another question in the chat coming up as to what should be watched out when deploying Llama 4 into production, especially in terms of latency or scaling.
So again, as I said, start with the model evaluation, right? So while I go through that model evaluation notebook, that's already covered with few of the criteria on how to compare the accuracy, robustness, toxicity, etc. So once you get the confidence out of the model evaluation, it will be very easy for you to roll it out into production. Of course, it's not like once you deploy it in production, you forget it, right? I mean, so there is observability in place as well. So there are multiple dashboards comes with both Bedrock as well as SageMaker. While watch out those metrics in place, and then continue to monitor and then fine tune the models if it is needed.
Excellent. So yeah, let's run through the demos now.
You may want to switch the window to Marcos.
All right.
Yeah, can everyone see my screen well here?
Yeah.
Awesome. Yeah, let's get to the juicy part of the session where we can dive deep into some code and really just answer a lot of the questions that we've been getting through some of these notebooks. I very quickly do want to highlight the Meta Llama on AWS GitHub. Within this GitHub, it has access to all of the different code demos that we're providing and we're going to be showing today. And you could simply just clone the GitHub repo and have access to any of the different demos that we're showing. So wanted to just quickly get that out the way. But for today's first demo, we're going to go over the long context window use cases, specifically leveraging Llama4 on Amazon Bedrock. And what we do here is that we want to be able to show how with the long context window, it supports up to a 10 million token. However, on Amazon Bedrock, it's about 3.5 million tokens. And we want to be able to show some of the different use cases that we discussed, such as being able to reason over extensive code bases, in addition to having a multi-document summarization use case as well. And to be able to deploy your Llama 4 model on Amazon Bedrock, it's really as simple as these three cells here, where you're importing Boto 3, which is the SDK that we'll leverage to be able to spin up our Bedrock runtime. Once we have our Bedrock runtime configured, you just need to ensure that you're in the correct region that Llama4 is supported on Amazon Bedrock. In our scenario here, we'll use US East 1. And then from there, you just need to identify what model ID we'll be leveraging. This is the model ID for Llama4 Scout. For Maverick, you would just need to change Scout to Maverick. And then essentially we have our Llama4 model deployed. We're able to be off to the races. We can leverage our model ID to start running inference on top of Amazon Bedrock. So here is what the payload would look like to be able to run inference on a Llama4 model. It leverages the OpenAI messages API format. So you can see that it will take a role as a user. The user will need to be the first role that's associated. And then we'll have a content, which is essentially a list of either a text or content that you would have that is pretty much guiding the model on what it would need to learn. So here we're guiding the model that it's a helpful AI assistant. And then our prompt itself is, what are 3 key benefits of large language models for businesses? Here we'll define our response, where we're calling the Bedrock client leveraging the Converse API. We're identifying the model ID that we've created here, and then we're taking the payload that we've created and wrapping the messages in a list. And here's our inference config. So we're identifying that the max tokens we want is about 2,000 tokens. The temperature is 0, so this is a deterministic response. And then the top P is 0.5. And here we can see the response of why large language models are beneficial to businesses. And here are some of the 3 key advantages. Not going to necessarily go too deep into that. Just wanted to show how you can quickly be up and running with a Llama4 model on Amazon Bedrock and start testing out different payloads to run inference. This is what I actually wanted to show here, which is the code base analysis. And what we want to be able to do is analyze an expansive code base similar to the one that we've leveraged here, which is the deep learning containers GitHub repository on top of AWS. And what I did prior to this session is I actually leveraged RepoMix. And for those that aren't familiar with RepoMix, what it does is it allows you to take a GitHub repository and put it into Markdown. And that's essentially what this Markdown file is. It's just the output of the entire GitHub repo. You can see that it has tens of thousands of different lines of code. And typically with a previous Llama model or a variant such as Llama 3, it only had about a 128K token window. So it would be very challenging for a model to be able to understand the context of this entire code base and then be able to synthesize it and output a response without having a framework like LangChain and leveraging a technique like MapReduce and having that whole entire pipeline set up to be able to get information from this. And even then, you still wouldn't be able to get all of it. You would have to define different chunking mechanisms and really define a pipeline that will fit your specific need. With Llama 4, we're simply able to create a few different helper functions. This one we're using to read a Markdown file. This one is essentially just to summarize the text leveraging Bedrock. And then not going to go too deep into some of the responses, but you could see, like, for example, I have a system instruction where I'm having the LLM be an assistant that will help me summarize a code base and understand what the code base means by synthesizing through the entire code base. And then the prompt is, can you explain to me what the build spec 110.2 YAML file is and how it relates to the rest of the Hugging Face directory? This is, in retrospect, a file within the entire directory, and there's a few different subdirectories within the code base, but we're telling it to understand what this file is and how we're able to what is the relation to this file with respect to some of the rest of the code base. So we have this set up in our messages API format, and then
What I'm curious is to see how long it takes to get that response, right? So because it's like I saw 495,000 lines over there.
A lot of lines.
Yeah,
A lot
yeah.
of lines.
So
it's
It was a
definitely a
lot.
line, and we have some code here where we're collecting some of the metrics. Here we'll see that it's able to read the markdown file in about point or 1.9, pretty much 0.2 seconds. And then the latency metrics for it to be able to understand the entire code base, synthesize it, and spit out a response was at about 10 seconds. So here we can see that it has a very accurate response actually on what the build spec file actually is and how it relates to the Hugging Face directory. And this is one use case that we'll see where you can take a large, vast code base and actually be able to synthesize what that code base is. So that's one example of
that
the.
example is an eye opener, like the repo mix, and being able to scan the huge code base, right? What do you
Yeah,
say,
I
Ram?
mean, if you think about like some of the companies that are out there that have inherited code bases from people that have, you know, left the company and the application works, but nobody really knows exactly what everything is inside of that, right? To be able to do something like this and look at the repo and get kind of a summary without doing the alternative, which would be, someone like me sitting in front of the screen trying to read the code through how many, what was that? 495,000 lines worth of stuff. Like that's a long number. That's a lot of time that would take for you to go through and trying to read through and like figure it all out. So you're like, nah, you just do this for me, Llama, and you tell me what I need to know. And it like does a really cool job of it. So
And what is the size of what's the model, right? Did we use Scott here? Is that Scott Instruct?
Yeah, this is Scout.
Scout Instruct, yeah.
Yeah.
Wow, yeah.
Yeah,
And
pretty impressive.
oh, go ahead, Rob.
No, go ahead, Marco. Sorry.
Yeah, I was just going to add that this is a very rudimentary use case as well, where we're just synthesizing it. You could think of a lot of the different ways you can leverage this long context window to be able to just use code bases and maybe have it synthesize the code base and debug what might be a potential security vulnerability or what needs to be improved. So there's lots of ways you can use this long context window to be able to support just code base analysis in general.
Yeah, no, it's very cool. My mind just went immediately to like the security side of it. And I was like, oh, imagine someone using this code to say, tell me what are the adversarial things that I can do based on this code base. Like, and it's like, let's go the other side instead of like, what does it do? Like, what can I do to this code based on what I know that you know about what's written in here? Lots of different things you can do.
I was just
right?
exactly thinking about another security use case. There's so many heaps of security files lying around, logs. Maybe throw them all around and then say, get me some insights. And so many use cases come out of this large context window support that's available here. All right. So next example here is what?
Yeah. So going into multi-doc processing, this was really cool. Just because I've worked on a ton of assets for Llama 3, and to be able to get information on different documents, you definitely would need to leverage a open source framework like LangChain and kind of set up your own chunking strategy and be able to grab information from just one document itself. What I've done here with this new context window is I grabbed about 10 or so different documents. These are all Amazon 10Ks um, in which we're able to grab information from all of these different 10Ks and extract the text from the PDF. And without necessarily needing to set up that entire pipeline, all I had to do was create a few helper functions, which was the to be able to extract the text. One to retry with exponential backoff. This is just because sometimes the model will actually need to have this backoff for throttling issues, and then a function to be able to extract key data once that information was extracted. What are some of the ways that we can what type of data are we looking to grab, like what year is this report for, what's the total revenue, the net income, etc. That this function essentially you can use to have a prompt that will grab the specific information that you're trying to grab there, and then another function that finds the PDF files and then finally synthesizes and answers what information you're trying to grab once it's all extracted. And then here, very similar, we're able to see how it's able to extract all of the information and pages from all of the 10 different documents. This document had about 194. This one had 83 pages. This one had 90 pages. It's a ton of information. This one had 85 pages, etc. Over 10 different documents, and we're able to see that once it was all extracted, it took about 6 seconds to synthesize that information. This cell in total takes about 30 seconds or so to run, and then we have a full report over 10 years of Amazon 10K revenue documents, and we're able to see how Amazon has improved and grown across multiple years, and see the different revenue growth from 2014 up until about 2022 or so.
So I guess one thing that comes up, and it's a question this actually came in from the audience as well, just over everything what we looked at, right, is accuracy to things. Can you talk a little bit about that, like in what you've seen so far with Llama 4 and the test that you've done with this and the other scenario, like, and it's a really important aspect, right? Because we're looking at the generative AI stuff is the accuracy and the results for things.
Yeah, so we're seeing that Llama 4 has very similar, if not better, accuracy than Llama 3.
Mhm.
Of course, you'd want to take those accuracy benchmarks with a grain of salt, and you always want to conduct your own benchmarks and testing across different like model evaluation scripts that you would provide, in which Chakra actually has a demo on that later in this call. So definitely just want to reiterate that in terms of accuracy, you want to ensure that you're testing that on your own. Um,
Yeah.
rather
So
than just
it's from data set to data set in a nutshell, right? So
Yeah.
we conducted a few experiments. So as per that, like we see either equivalent or better performances compared to Llama 3. But while it may differ for your own data set, that's the reason like we published the evaluation framework for you to try it out on your own data.
So I think if we have some time, maybe we could just, I know we're kind of getting closer to the end of the hour, but we'll see if we can speed up things and try to show the evaluation as well.
Sure. So we'll move on to the next notebook to focus on the vision use cases. So appreciate if you can help switching the window.
All right, so let's do that. And while we are waiting for the window to be switched, there's one thing coming up in the chat, which is on the token limit in Bedrock.
Yeah. So as I mentioned earlier, 3.5 million. It's a context length, maximum that that you can use within Bedrock, and we are still working on to get into 10 million. But at the same time, as I said, you have an option to deploy it in SageMaker with 10 million context length as well.
Thanks.
This is on Scout. For Maverick, 1 million is the maximum that is already supported.
Sure.
Right.
All right.
Okay, so let's moving on to the vision use cases. I just quickly wanted to show while Marco demonstrated the text based demo on multi-document, long context, etc. So how do you do the image based? Because as this is a multi-model, you can also use the images, right? So
Do you
I'm
want to zoom in a little bit, Chakra? Yeah.
is it better?
Yep. Better.
Okay.
Thanks.
So I'm starting with the model selection. So this is again the foundation model IDs of Bedrock. So this specific notebook is based on Bedrock. We also published few notebooks around SageMaker. So watch out for that blog. We are going to share at end of the session. So how can you know this foundation model ID? So with Boto 3, there is a command. You can list the foundation model ID to get this model, or just refer to the Bedrock model, Bedrock documentation. So just simply select which Llama 4 model that you want. And then same Bedrock runtime client of Boto 3. And then there is a small helper function to create messages based on the format, the same chat template what Marco mentioned earlier, like a role of a user and the system, right? So this is a very simple vision demo. It has got only one image. So it has got a chart and there is a question is being asked. And then, it explains what is there in the chart, right? So that's a very simple single image based. Well, I wanted to quickly show you that multi-image also. Um,
Mm-hmm.
Okay, so this is a kind of a small function. As you have seen the messages template earlier, it has got only one text-based prompt and one image. It has got like two different images. Likewise, you can also stack up to 5 different images. So Bedrock supports up to 5 images. Not only Bedrock, Llama 4 models themselves supports up to 5 images. So you can just provide it. This is a kind of a helper function. So don't think that I'm just running through this demo. The same notebook is also available in our repository for you to go through the details. So you just simply read that image and then pass it on to the chat template, and here is where it is, right? So there are two different slides talks about the results, and it just simply explains what is there in the slides, right?
Okay. No, that's cool to see like the different things you can do. Like I said, because of the fact that it's multimodal and everything like that, being able to take advantage of both sides of things and being able to look at what we saw before with all the code and everything. And then now getting into like being able to take that and use it to generate these different, slides that you can then use for presentation type items and save your time on that too, right? Like there's a lot of things. I just think of like some of the different things we can do internally that we've had like for different tools that we've used, like Old Life is like generating slides a lot of times, right? That takes time with the data and putting together all your different charts and stuff. And now you can kind of have it do it based on those data sources and have that kind of taken care of for you. So cool to be able to see a number of different things that we've gotten there. Now we're kind of button up close into time here for today's show, but I appreciate like everything that you all have been able to show us. Is there any one last thing that you kind of wanted to really kind of hit on real quickly in the next minute, basically, to
Exactly.
kind of close
So
out?
I just want to quickly conclude with the model evaluation, what I was talking about, right? So
Sure.
we published an automatic model evaluation notebook, which leverages the Amazon Bedrock's model evaluation, where you can actually, there are multiple built-in data sets available for you to evaluate along with the metrics. Like, for example, in this case, I'm evaluating with accuracy, robustness, and toxicity. So using these notebooks, actually, you can create multiple dashboards on comparing the model-to-model performance in terms of accuracy or robustness or toxicity, and also with a custom data set, for example, right? So I've just created a very my own data set for the demo purpose, which shows the average metric between Llama 4 Scout and then 3.3 Llama 3.3.
Okay.
It shows almost equivalent, but this is only for the demo purpose. As I said earlier, this varies from data set to data set.
Yeah, varies from data set to data set. Yeah, for sure.
Yeah.
And a question out there, Chakra. So these images, right? So does this Llama 4 generate images, or are you using
No,
Python?
so it takes input as an image as well as text. The output it generates only text.
Right.
It does not support the image generation.
Okay, cool. Well, I think we've gone through a lot. I think one of the things we wanted to make sure that the audience had is a little bit of information they can take away with them today. So we've got a few different QR codes that we're just putting up here on the screen, so you can get your phones out if you want to be able to scan these and take a look at some of the information for the Amazon Bedrock documentation on Metas Llama, and then just the other links that we've got here on as well as that GitHub repo, right? So
yeah,
if you
and
missed it in the chat, it's there.
Yeah, this GitHub repo has so many examples out there, so it's like definitely going to help you in your development process, right? As you comb through those examples. But
Yeah.
Chakra and Marco, thank you for sharing a whole lot of stuff on Llama 4 here today with all our viewers.
It's pleasure talking to the community. Thanks for providing us this opportunity.
Thanks for having us.
Yeah, and thanks everyone for watching today. Really appreciate you coming and tuning in, asking the great questions that you were able to. Sorry we weren't able to get to every single one of them. Saw there was some that were still coming in as we were just trying to wrap things up. So appreciate it. And I'll let you close out the rest.
Yeah, I think we are here. We're at the end of the hour. Come back next week for another show and tell. We are potentially looking at a model distillation. The t-shirt model and all of that, right? There's a lot of lingo around that, so we'll probably explore more when we get to the next chat, right? But for now, this is the end of this session. Thanks a lot for you tuning in.
Thanks, everyone.